then join me at the carpet.
Pins can be magnets because
going to listen to our partners, we're going to listen to our group, and we're going to listen to me, right?
Yeah.
We're going to write down how we're going to solve the problem using a magnet. Okay? Capiche?
Capiche.
Everyone can do this?
Yeah.
Absolutely. Both have magnet, magnetic field, attraction, repulsion, compass. Magnet, a piece of material that attracts iron and some other metals. A magnet has two poles, a north pole and a south pole. Magnet, magnetic field, area around the magnet. If you sprinkle iron fillings around a magnet, it will show you the magnetic field. Magnetic field. Attraction. North pole and south pole pull each other. See this? North pole and south pole. A couple of you were confused when we had you write your findings. You said two like poles, but it's two opposite poles, right? Two opposite poles attract. Okay? So, two opposite poles attract. Repulsion. Two north poles, two south poles push each other away. So, if you put two like poles together, they will repulse. Repulsion. Do it with me. Repulsion. Pushing each other away. Compass. A navigational device that uses a small magnet. We use a compass to tell us where the Earth's north pole is. A compass. So, we're going to create a magnet today. Can I get a yes? When you see the paperclip, nifty-nifty paperclip that the darling Scarlett showed us, they are unmagnetized. Okay? These two paperclips, can we all agree with that? They're unmagnetized. They're not picking up. It's because their electrons or their alignment is all over the place. It's not where if something's magnetized in a straight line, like how you guys line up, that's how a magnet is. It's all lined up. Like how you are right now, you guys are magnetized. Except back there, you guys are all over the place. Therefore, you guys are unmagnetized. See that? What? Well, no. I mean, if you put it towards, like, if you rubbed it on a magnet, do we rub it like this?
No.
We'll rub it the same way, right? No, and then it will become magnetized, meaning all of its stuff, all of its electrons are lined up. All the arrows are pointing the same way. So we're going to watch a short video, and she kind of explains this. Bill Nye kind of explained it. I don't know if you guys remember that.
Hi, my name is Christina, and I work at the Canada Science and Technology Museum. And today, we're going to talk about magnets. Like these. Magnets are everywhere, including in things like doorbells, speakers, scrap metal sorters, and even this board. Inside this board, there are actually thousands of small magnetic objects. This pen is actually a small magnet, which attracts all these magnetic objects to the front of the board where we can see them. The eraser is another magnet behind the whiteboard that pulls the magnetic objects back and out of sight. So you've probably played with toys like these before, but have you ever asked yourself what a magnet is? A magnet is an object that has a north and south pole and creates a magnetic field. Magnets are typically made of metals such as iron and cobalt. The atoms of these metals form clusters called domains. Imagine that these candy pieces are the domains inside this metal bar.
So you see the domains, how they're all
When
joined
the
up?
domains are not aligned,
They're
like
not
this,
aligned, they're not in a straight line.
the metal is not magnetized. It is only when most of the domains are aligned in the same direction that the metal becomes a magnet. This is a bar magnet. When we put the bar magnet on a board containing iron filings, we can see the lines of force of the magnetic field. When opposite poles of a magnet are brought together, the lines of force join up and the magnets
So
pull
there's a
together.
north and a south pole pulling each other.
When like poles are brought together,
See how it's pushing
the
away?
lines of force push away from each other and the magnets repel. When poles are not well aligned, the attraction or repulsion is not as strong. These are really strong magnets. When they're joined together and opposite poles are aligned, the attraction is so strong that it can support up to 200 pounds. But when we unalign the poles, the magnets become easier to separate. And that's how magnets work. The Canada Science and Technology Museum has many artifacts on display that contain magnets.
So now we're going to create our own magnet. Yay! Okay, so we're gonna be separated into 3 stations. And how we're gonna do this, how we're gonna split up is in your math groups. What groups are we gonna be in?
Math group.
Thank you. So, the first ones are gonna go fishing. Remember we went fishing for things that were magnetic the other day? Yeah. So, with your partner, because you're gonna pair up with a partner, you're gonna get a red card and a blue card, okay? I have 9 and 2. What do you think we're gonna do? Multiply them. We're going to multiply these numbers together. And whichever partner gets the highest number wins, okay? And keep doing that until, for 5 minutes, okay? All right. So, everyone stand up. Put your clipboards away. We're going to walk to station 2.